I guess I'll just stand here in the middle. Can you all hear me?
Yeah.
What?
You're good? Okay. Welcome to Doing Builders. This is Caddy. My name is Matt Holt. And thank you, Inside Sales, for putting this on wherever you want. Appreciate it. It's awesome to have this meetup in Provo, so I don't have to travel now. And so tonight I'm going to talk about Caddy and introduce you to this. It's a web server. It's written in Go. But most of the content is going to be about the technology that Caddy uses to serve your websites. If you have questions, if they're quick questions, then go ahead and ask them in context. That might be easier, but we'll do some question answer at the end as well. If you like what we talked about here tonight, then you should follow me on Twitter at mholt6 because I like interacting with people online who have similar interests. And I tend to tweet stuff. So anyways, I guess we can get started. So Caddy is an HTTP2 web server. It's powered by the Go standard library. So your Go applications use the same underlying code base that Caddy does. By the way, if you want updates about the project, you can follow Caddy on Twitter at Caddy Server. Caddy is an easy web server to use. You just CD into your site's folder, and you run the Caddy command, and it will serve your website out of that folder on localhost port 2015. And if you want to serve a production website, you do the same thing, but all you have to do is tell Caddy the domain name, the host name that you're serving on. For example, just using the command line option host. And this will serve your site over HTTPS and HTTP2 in a matter of a couple seconds. Caddy has a very easy configuration that we'll talk about, so you won't have to spend a half day configuring the web server for most things. Caddy also will make you more productive as a site owner. It's in the sense that it offers you some capabilities that you would just want on a modern website. If you think of it this way, every few years, a new layer is added upon some underlying layers of technology to make our lives easier. For example, we're seeing intelligent chat bots as a new technology it's kind of wrapping messaging platforms and messaging protocols so that we can still be productive with messaging, but without having to worry about the underlying layers. And in this way, Caddy is similar. You can set up your website without having to worry about the server layer and all of that is kind of abstracted, and you'll see that here as we show you how to use Caddy. It's abstracted so that you just think about your website, so you don't have to think about the server element of it. Caddy is also the only web server that ships with quick support, which this is a new protocol. Some of you maybe have not heard of it, and that's okay. We'll talk about it. But it makes HTTP2 faster. It's also, Caddy is very highly extensible with plugins. And yes, it's a Go program. There's no magic here, though. I'll show you how that works. So these are what we're going to talk about tonight. But a brief overview of the project. It's grown a little bit in the last year. I didn't really expect this. It has over 90 contributors to the code base. And I don't know how many downloads it has because I don't count that. But it has at least 30,000, I think, from Google Analytics and GitHub graphs. It is used in production and in development quite often. It's used internally and it's used externally. Netflix uses it for a monitoring dashboard. Laravel, if you're a PHP developer, you've probably heard of Laravel, the Valet product ships with Caddy. GopherCon websites use it. A German hosting company uses it for their website. I know the meetup event description did say that, count the GitHub stars and be impressed.
That was me.
Was that you?
Yeah, sorry.
That's fine. So 7,000 stars is nice, but here's how I use GitHub. Oh, that project looks neat. Maybe I'll use it someday. Star, and then I never realize it again. So we have 7,000 people at least that are not using it. But Caddy is recommended by several internet security experts because of its default security configuration. We'll talk about that. And then recently it was awarded some funding by Mozilla. We have some ambitious plans to make Caddy more available to less technical users and to improve its build infrastructure so that you can you basically just, we're going to put the download page on steroids. You can go to the Caddy website, by the way, if you want, kind of browse around, look at docs. Even while I'm talking, that's fine. The download page is really key to Caddy's usability, though, and that needs support. So we are looking forward to the future here. Now, if you want to do anything more than just serve static files with all the default configuration, you're going to need to know how to configure Caddy, but it's really easy. And for this, you use the Caddy file, which is just a text file that you put on disk next to your website. And when you start Caddy from a folder that has a Caddy file in it, it will just use that Caddy file. And with the Caddy file, you think in terms of websites. So you start by typing the address of the site you're going to serve, and you hit enter, and then you describe the qualities that you want your site to have, or the behavior that you want your site to exhibit. So here we want to enable compression, so we type gzip, and then we hit enter. And then we have our site written in Markdown, and we want to render those as HTML files, of course, so we type Markdown, and we hit enter. And then we have a local service running that we want to proxy the API request to. So we can do that with proxy, and we hit enter. And then we also have a WordPress site, maybe a blog set up. And we need to, of course, that's powered by PHP, so we use FastCGI for that. And we hit enter. And by the way, this PHP keyword at the end is kind of a preset configuration to make it really easy. It just tells the FastCGI middleware to serve PHP specifically. And so it kind of gives you an optimal configuration for PHP sites. And then the last question, I guess, that would remain is how to deploy your site. I like to use Git. I like to just git push. And so this is a Caddy deployment. I just type git, and then I type the path to the repository. And every hour, Caddy will pull changes and redeploy my site for me. So in 6 lines of configuration, you are more productive than you were with maybe what you were using before. And that's kind of the idea here. And there's no syntax to get in the way. You don't have to worry about punctuation and other little things. This is very easy to write. You can write this in a minute. So I'll show you how this works then in practice. Now this video is only 28 seconds long, so pay attention. And you'll see me start serving a website, just a static site. And it's also going to showcase one of Caddy's premier features, which is its automatic HTTPS. So we start by creating a Caddy file. And in this Caddy file, I only have the address of my site, but I can put more there. And then I start Caddy. It negotiates a new TLS certificate, and then it's serving my site. So when I load it in the browser, I just go to my site, and it also redirects HTTP to HTTPS. And this connection has been protected by a certificate with from Let's Encrypt. And as long as the server is running, it'll keep that certificate renewed and installed and updated, and you don't even have to think about it. There's really no reason that we aren't using HTTPS anymore. So that's Caddy in a nutshell. That's the end of my introduction to Caddy. We should talk about security and how this can relate to your own Go programs. And so often, I mean, when you look at this, you see how easy this is to do. This is a normal experience. When you think about security and usability, often we view them as adversaries. But, and the reason for that is fairly obvious, right? If you have security, you have more verifications, more checks, more things to remember, more things the user has to have with them. But what if we could turn that problem on its head a little bit and use usability to our advantage as an asset to our security? What if we could make a program so usable that you can't get the security wrong unless you're thinking about it and trying to turn off the security? So I call this security by usability. And in Caddy's case, this means that it obtains and renews TLS certificates. It staples OCS. This means that the browser will always have the correct and current status of the certificate. If it's been revoked, then the browser will reject it. So this protects your site in case of a problem. And Caddy is also the only web server that will rotate TLS session ticket keys. And this preserves perfect forward secrecy. So if someone is recording encrypted transmissions and then later the server is compromised, they can't go back and decrypt all those transmissions. If you rotate the keys, it limits the window of damage. So, and it does all this without being asked, and that is the key. You can turn all this on with other web servers. You can even use Let's Encrypt with other web servers, but you have to go in and configure that. Caddy does this without being asked, and your Go programs can do this too. So let's talk about TLS a little bit. Before we dive into how Let's Encrypt and Caddy does all of its magic, we need to agree on something. We need to agree on the answer to this question. Do you need TLS? I'm going to tell you that you do. And I'm not going to be the only one that tells you. You're going to tell you that you do by the end of this, I hope. And all the security experts in the world, one of which I'm not, will tell you that, yes, you need it. Now, I found only 2 exceptions to this. One of them is, and I actually had asked Twitter for help coming up with a reason that you don't need TLS. And I came up with 2. One is that your program does not use the network. If you don't have a transport layer to secure, you don't need transport layer security. If you are using the network, but it's just a loopback interface, you also probably don't need TLS. If someone is snooping your loopback interface, you have bigger problems. The other reason you may not need TLS is, and this is the one that people try and wiggle themselves into if they're feeling lazy or if they're misinformed, or, I don't know, they just think everything's unicorns and rainbows. They'll try to convince themselves that their threat model assumes that their transport is already trusted. And what I'm saying here, this is a big claim. This is not just, oh, it's an internal network, we're good, or we're on a VPN, it's okay, or, oh, we're already writing an SSH connection, it's okay. We're talking about 4 really significant aspects here of security of your transport. When we think about TLS, when we think about encryption, the first thing that will often come to our mind is confidentiality. Now this aspect is obvious. We encrypt to keep our communication private. So you have to be able to guarantee, if you're not going to use TLS, that your communication is private, whatever that means to you. Authentication is the next big question. Who are you talking to? Are you talking to the machine you think you're talking to? The machine that they say they are? If you can guarantee that no one is spoofing anyone, or imitating anyone, or intimidating them, I don't want that on your network either, that's me, then fine, authentication's covered. Now this third one is a huge, and we often forget this. This is always ignored by the TLS critics. They forget about integrity, content integrity. Are your transmissions between being sent and being received, are they being changed at all? There are 3 reasons that people might change content as it's going down the wire. One is that they're a bad actor and they're knowingly trying to attack your transmission. The second one is that they are not a bad actor in that they're not trying to harm you, they're just trying to be helpful. We see this with network firmware a lot, middle boxes that think they're being helpful and they optimize your HTTP packets that aren't actually HTTP packets. This is why HTTP 2 is not implemented in plain text by most browsers, any browsers. Is because we found that middle boxes think they're being helpful and they change the content. Another thing to think about is if you have a website and there's no sensitive information on it, nothing private, nothing personal, no passwords being transmitted, no names even, it doesn't matter. You're not using any advanced features in the browser like geolocation. Why do you need TLS? Because your website is a liability. And if people are changing the contents of your website between your servers and your visitors' browsers, I'm not a lawyer, but that is a liability for you. Because your family-friendly website all of a sudden is full of explicit advertisements or malicious scripts. And there's no way you can detect that because there's no compromising your server. Only TLS and proper MAC authentication and those kinds of things can guarantee that integrity has not been compromised. Okay, I beat that one into the ground. That's important. Oh, and I grew up, by the way, I grew up in rural Iowa. We had satellite internet, thanks to Jonathan over there, who suggested it.
They had dial-up before. I'm like, it's some kind of high speed. So satellite with like 500 millisecond latency was still a good thing.
500 milliseconds on a good day. It was usually about a second to get across the street. The thing about satellite internet is if we had wind or rain or snow, we would have packet loss. And TCP checksums are only, I think, 16 bits. And it wouldn't cover everything. But TLS, MAC authentication, gives you complete end-to-end integrity checks. And that would have vastly helped. I thought that all these big downloads were successful, only to get an hour into my game or my movie or whatever, legally downloaded, and only to find out the download was corrupted. Anyway, so those are these little things, user experience. YouTube this week just turned on HTTPS for all their streaming, well, 97% of it, and they found that streaming errors were reduced with HTTPS because of integrity checks. Okay, so the last thing is non-repudiation. If you can guarantee this in your transport layer without using TLS, that's fantastic. Non-repudiation means that the parties involved in the transmission can't deny that they were involved, that they were party to it. So this usually invokes the use. This usually means that the use of a private key was invoked. Did I say that right? In a technical level, that's basically what it means. So anyways, it's a big claim to say you don't need TLS. Huge claim. So how does Caddy do it automatically for you? How many of you have installed SSL certificates? All of you, except this guy. So, how many of you liked it?
It is a pain.
Was it a pain?
Yeah.
Okay.
It's one of those things you don't want to be good at.
Yeah.
I am ashamed to admit I have generated CSRs more than I care to count.
Yeah.
So yeah, you have to generate the private key, you have to generate the CSR, you have to paste that into some form in a browser, which is always secure. You have to submit that form, no problems there. You have to buy some things, and then you have to check your email, also not a security problem. And then you have to install your certificate after you've downloaded it and restart your server. What could go wrong? Nothing's ever gone wrong, right? No one's ever let their certificate expire. No one has ever lost their private key. No one has ever, I don't know, exploited web forms. Anyways, there's a new protocol called ACME that allows Caddy to be able to do this automatically. And the certificate authority which implements ACME is called Let's Encrypt. These guys are fantastic. There are 3 ways using the ACME protocol to prove that you own a domain name. The first one is the HTTP challenge. This one, we'll talk about in a second. It looks like this. Your server's in the bottom right, the DNS server's in the bottom left, and then the ACME server, or the certificate authority, is at the top. The TLS SNI challenge is the second one, which looks similar. And then the DNS challenge is the third one, which is a little different. Now, the details of these challenges, we will look at these because I want you to use these in your Go programs. There's an excellent library out there called LeGo. It's by a computer security student in Austria named Sebastian Earhart, and he's been working on it for over a year now. In fact, I was looking for someone to help me implement the Acme protocol for Caddy a year ago, and he stepped up and said, I'd like to do it, so he did the whole thing, and he did a fantastic job. And it's pretty well battle tested at this point. It is, I would say it's the premier Acme client library in Go. It's pure Go. So if your Go program uses http.listenInserve TLS, or if you're calling that.listen to anything outside of your loopback interface, you should probably use LeGo. So if you're going to use LeGo and the Acme protocol, you should know how these work. This is why we're talking about it. But if you're just using Caddy, the details of this really are not important because Caddy does all three of these challenges, and it can do the first two for you without you having to think about certificates. In fact, the HTTP challenge is the one that you saw in that video that we showed. But from the outside, they all look the same because this is all under the hood. The HTTP challenge basically is when your server serves a resource at a certain HTTP endpoint. So the Acme client, which in this case might be Caddy or your Go program, communicates with the Acme certificate authority saying, hey, I want to solve the HTTP challenge for this name. They do a couple exchanges of some cryptographic nonces and tokens, and they come up with a resource that you need to place at a certain URI. And then once you've got that set, the Acme server does an authoritative DNS lookup for the domain that it's issuing the certificate for. And then it makes that HTTP request, and if it sees that resource there, then it knows that you must own the domain name. Excuse me. And at which point, the validation has succeeded, and you can download your certificate. Notice that you need to open port 80 and have it be accessible from the outside in order for this to work. But Caddy will do this by default. And in most cases, this is not a problem. The TLS SNI challenge is very similar, except that instead of proving your control of the domain name at the HTTP layer, you do it at the TLS layer. And you do this by solving or by completing a special TLS handshake. So similar thing, you initiate the transaction, they do the DNS lookup, and then the Acme server tries to complete a TLS handshake using the SNI extension. You agree upon a special server name that you use in the SNI field, and if you can complete that handshake, then you are awarded your certificate. You read. This challenge is a little trickier in some infrastructure scenarios because you can't use it behind a TLS termination. You do have to open a low port, like the HTTP challenge, and if you are behind like a proxy or a load balancer, like I said, they have to be specially equipped or configured to route the challenge request, to route all the bytes to the right server. So again, normally this is not a problem. Like if you just spin up a new cloud instance and you run Caddy from there, it'll just work. But if you are in a complex infrastructure scenario, your Go program is being run internally, you would be interested in the DNS challenge. This challenge does not require you to open a port, does not require your machine to be accessible from the outside. All you do is you have to set a text record in a DNS text record in your zone file. So again, your Acme client will initiate the transaction and say, hey, I want to use the DNS challenge. Then you have to set the text record that the Acme certificate authority gives you to set. And then they do the authoritative DNS lookup, but instead of using it to make a request to your server, they just look at that text record. And if it has a certain value, then you've proved ownership of that zone, and you get the certificate. And then the Acme client will clean up that record after the challenge is completed. LeGo supports 12 or so providers right now, DNS providers, so that they can do this automatically. Most implementations just show you the token value that you need to set, and you have to copy and paste it into your control panel, and you have to hit enter to continue. And you can do that with LeGo, but LeGo supports 12 providers like Cloudflare and DigitalOcean and Amazon, Google, and others. So in a matter of about 2 to 10 seconds, depending on how fast your DNS provider applies changes, it can solve this challenge. The only catch here is that you have to turn this challenge on. So but the thing is, you only have to turn this on if you're in a difficult situation anyway, if you're in like one of those advanced infrastructure setups. And it's really easy to do. It's one line in the Caddy file. You just have to set environment variables with credentials like an API key for your DNS provider so that Caddy can go in there and set those records. So here's an overview of 3 Acme challenges compared also to traditional domain validated certificates. You don't have to remember this, but if you do use LEGO, you should have an understanding that we just talked about. Are there any quick questions about that?
You define your own DNS provider. So in a completely closed network, I might have an enterprise who has a DNS for the infrastructure on the network that they have, but no outside access. Or the installing machine for other machines is the DNS provider for those machines.
Okay. So your question is if your DNS provider is also internal, how does it work? Can it work? As far as I understand, the answer is no, because Acme and traditional domain validated certificates rely on authoritative public DNS. Again, this is a public third party that is vouching for you, and if it can't have access to your internal system, it can't vouch for you. And even if it did, why would it trust your internal system? So, that is not, as far as I understand, supported. But, of course, there's the age-old solution of becoming your own certificate authority, and if you are running your own internal DNS, then I imagine this is an entirely internal network, in which case you don't need a trusted third party to sign a certificate. You can become your own certificate authority and have all of your internal systems trusted and then just issue those. Now, you can run your own instance of Boulder, which is Let's Encrypt's implementation of the Acme protocol, the server side. So if you run your own Boulder instance, you can still run your own internal Acme instance, and you can configure Acme client and all the machines that use it to use that internal Boulder instance.
Okay.
And then the auto provisioning of the certs
Yep.
for Caddy.
Yes. Set the certificate authority's URL, because every Acme endpoint starts at one URL. And you can change that URL to an internal location, so Caddy can use your own internal Boulder CA. But that certificate, of course, won't be trusted out in the public. So, good question. Now, interestingly, this has generated some misinformation. I think that it's because there's a lot of excitement about it, which is good. But there seems to be some pushback, and I want to just kind of settle some things down. First thing I hear a lot is that Go is inefficient, its TLS implementation is immature, its TLS overhead is too CPU intensive. That's mostly false. Go's TLS implementation is very good, and its crypto implementations are largely in assembly now. And most machines have hardware acceleration for cryptographic instructions. So we're not looking at a huge CPU and like your CPU isn't going to spike like crazy. Cloudflare is using Go TLS implementations, and if Cloudflare can use it, you can use it, I guarantee it. Network overhead is irrelevant for most people. We'll talk about some technologies that are reducing that. Some people often confuse Let's Encrypt or conflate Let's Encrypt with Acme. Acme is the name of an open protocol that anyone can implement. Any certificate authority, any individual, any organization can implement it themselves or use their open source implementation of it, which is also written in Go. Let's Encrypt is the name of a certificate authority that it's a brand name that happens to be right now the only certificate authority that offers Acme, but I'm hoping that there will be others who do, because why not? Short certificate lifetimes are burdensome or unmanageable. So the reality is that Let's Encrypt certificates are valid for 90 days, not a year, not 2 years. This is a security benefit because if your private key is compromised, it again limits the window of damage. And the reality is also that if your tooling is good, certificate lifetimes don't matter. They just go away because you don't have to think about it. As long as Caddy is running, for example, it just keeps your certificates renewed. Who cares how long they last? I believe Let's Encrypt wants to eventually shorten that expiry window to 30 days or 7 or whatever, I don't know. But if your tooling is good, then these are completely manageable and not burdensome because you've automated everything. We used to say the same thing, by the way, about lots of little virtual machines in the cloud that is now the cloud. We love it because we automate it. Anyways, people love their wildcard certificates. Let's Encrypt does not offer wildcard certificates. It's not to say that some other certificate authority can't someday, or that Let's Encrypt won't, I don't know. Why do we love wildcard certificates?
Well, if you have multiple, oh, go ahead.
Because at the point that you have hundreds of customers, each with a custom subdomain, anything else is a pain in the butt.
Yeah, because you have to manage it. You have to move those around, you have to get those new certificates. But with a wildcard certificate, you just use that line, just replicate it out to the new machine. Well, if you automate the issuance and renewal of certificates, that also goes away. There's one machine I know of, it's an EC2 instance, that is running, it's running Caddy, and Caddy is managing tens of thousands of certificates for tens of thousands of domain names. None of them are SAN certificates, which Let's Encrypt does issue SAN certificates. Caddy doesn't, to keep things simple, and it doesn't matter, again, it's all under the hood. But no need for a wildcard certificate, it's running great. Another thing I hear is that Acme is not secure. It's only a year old and whatever, less secure than traditional methods. Wow. So Acme is more than a year old. It has been developed over several years out of research coming from the University of Michigan, I believe. J. Alex Halderman and his research team have worked on it initially, and has been pretty well vetted over the last year. Now, is it perfect? Probably not. Is it good? It's pretty good. All the known vulnerabilities have been fixed. It's still in beta, and the certificate transparency, of course, has mitigated a lot of any exploits. Only a couple, and they were not severe. Less secure than traditional methods. I don't even know where that comes from, but I hear that. Traditional methods require the use of the browser and the use of email. Acme has a much smaller attack surface, requiring none of that. In fact, this week I read about a vulnerability that was disclosed in Komodo's certificate issuance process. It didn't even involve JavaScript. They injected a form into their form, submitted the form, and then the email that came through was where the exploit was. And so clicking on the link in the email, as usual, gave someone else the permission to obtain a wildcard certificate for your domain. That's impossible with Acme because it doesn't use email and it doesn't use forms on the internet. Anyways, I also hear that free certificates are worse than commercial certificates. This is false. I don't know what people are talking about. Commercial certificates, maybe they mean extended validation certificates, in which case they're not worse. The free certificates that you get from Let's Encrypt are domain validated, but cryptographically they are equivalent. Even the ones that you generate yourself are cryptographically equivalent. It's just a matter of how much you trust it, how much your clients trust it.
Well, that statement probably comes from what historically has been a pretty shady business with free certificates in the past.
Yeah, so people have tried to make free certificates a thing, and it hasn't gone great. And there's also, and then there's just the notion too in general that free stuff can't be as good as paid stuff. Well, when it comes to cryptography, if the cryptography is sound, then that actually can be false, and the free stuff can be just as good. So, yeah, domain validated certificates are fine for most things. In fact, browser vendors have plans to deprecate the green padlock for domain validated certificates and just show nothing of interest there. They'll show warnings, hopefully, in the future for plain text HTTP. But the idea is that extended validation certificates will always be relevant because as everyone moves to HTTPS, which is just the standard domain validated certificate, then businesses will be more inclined to pay for extended validation certificates and give that extra trust, which is why I think the last one is also false. But it's also true because how many years has it been since the certificate authority industry really innovated? Acme didn't come out of the CA industry. It came out of academia. Anyway, so don't worry about it. TLS is great. It's good. Use it. Let's Encrypt is great. Use it. Burn this image into your mind. Remember that when you don't encrypt, remember this look that Gandalf is giving you. This dying wish. Okay, so that was a pretty in-depth look at Caddy security features and Acme and things you should know for your own Go programs that use the network. We're going to take a 10,000-foot view now at a couple of these other topics. So HTTP2, what is it? It's a new, have we all heard of HTTP2? It's okay if you haven't. Okay, I won't go into detail. So it's Go 1.6 supports HTTP2 by default. Go 1.7 usually does. That was a fun little bug that I just bumped up into last week. But Go 1.7 should come out next week. I'm really excited about that. Brad Fitzpatrick has been doing great work on the HTTP libraries for Go. So if you're using HTTP.listen and serve, and you are using it over a secure connection, HTTP2 will be the default that's used there. HTTP2 is a binary protocol, so it's more compact on the wire, meaning it faster transmissions. Its main speed benefit, though, comes to the fact that you get multiplex streams over TCP. So the idea here is that a browser doesn't have to open 6 connections to download 6 resources at once. It just opens the one, and then the packets that are coming along that one connection, the one packet here may be for resource A, and the next packet behind it might be for an image, and the next packet might be for a JavaScript file. So it just kind of interleaves them all. And you get a huge speed boost that way. HTTP2 is a complicated protocol, by the way. It is not like HTTP1, which is simple in comparison. HTTP2 has something called server push. This means that if a client requests a resource like an HTML file, that the server can send that file as well as JavaScript and HTML and images and HTML or style sheets or whatever else it needs without the client having to ask for it. That's also a speed boost. The thing is that the details of implementing it are up to the application. So this is not defined in the spec, and for good reason. It really varies widely. The Go standard library does not yet support server push. That's okay, I think they will eventually, but and I have some ideas about how Caddy would use it. But there are a couple different implementations floating around that use different ways of doing server push. The most naive thing I can think of that honestly I kind of like this idea is just when you're serving an HTML file, just kind of parse it really quick and get links to all the same domain resources that it might need and see if you can kind of load those up and push them out right away and then just cache that result for the next time that file is requested. Other people use link headers. It's just kind of however you want to do it. The heuristics are undefined, but it's a cool technology. Stream prioritization is another benefit of HTTP2. I don't know if the Go standard library supports that yet. Does anyone know? I don't know. Header compression, it does. That's HPAC. So your big cookies are small, which if you're eating cookies, that is not a good thing, but over the wire, it's a great thing. Any questions on HTTP2? Caddy enables this by default for any production website. Again, HTTPS is required. Yeah?
So I'm curious, where's the rest of the industry? Like .NET, Java, do they have HTTP2 support? Or is it just a Go cutting edge thing?
It's a good question. Does anyone know?
The main Erlang servers support it.
Erlang does?
I just have anecdotal stories, but I work for Walmart.com, and I believe we were one of the first servers in the whole company to roll out HTTP2, and we just got it for free because we're using the Go static library. So.
Oh, cool.
And it's a lot of the servers that are Java enterprise stuff, so that's, yeah.
That's cool. Yeah, and I have gotten a lot of questions. People put Caddy in front of their Java applications or Python or whatever, and they ask, well, is HTTP2, is the benefit nullified because proxying to the back end, it's HTTP1? I don't actually know, I think it depends. But it sounds like they aren't using HTTP2 in the back end of their platforms. The rollout of HTTP2 should be growing more. Cloudflare is doing it, so a lot of the internet is already encrypted and over HTTP2, which is cool. Anyways, I think Nginx and Apache support it, of course. As far as other languages, I'm not sure where they're at. Okay, the last web technology that we're going to look at, again from a high level, is Quick. Quick is a protocol being developed by Google that increases the speed of HTTP2 because it doesn't use TCP. So you have reliable transport over UDP, which is really cool. And this has been being developed for a couple of years now. Only Chrome supports it experimentally, although I would not be surprised if you go to google.com in Chrome, and then you click in the inspector tools, the developer tools, if you go to the security tab, then you have to reload the page, but then you can click on the request there, and you can see if the protocol should be Quick. You might have to enable a Chrome flag. I'm not exactly sure. Chrome 52 changed a couple things.
That sounds harder than getting an SSL cert.
Yeah, yeah, it's yeah.
Which is saying something.
Yeah.
Right, the day we live in, can't figure out what protocol we're using. So Caddy's the only web server to ship with Quick support. Google has an experimental Quick server that you can kind of play with, but this is the only actual web server that you can use it as an experiment. Again, just start Caddy with the Quick flag. So how this works, and the features of it are really cool. I'm actually going to click on this link here, and because this blog post by Matthias is fabulous. He has pictures, and that's really annoying, so I'm going to just get rid of that. There we go. So this is what a TCP, when you establish a TCP connection, you have to go through all these round trips for the TLS handshake, or TCP handshake. And then once you've established a connection with TCP, then you need to establish a TLS handshake, which is this. So lots of round trips. With Quick, this is what your handshake looks like. And the reason for this is, again, because it's built on UDP. And his article explains, this is an amazing article. After you have connected, so to speak, the sender to the receiver, the second time you do it, you don't have any handshake that you need to perform at all. This is where Quick fits in the stack. So you've got IP, of course, and then instead of TCP and TLS and HTTP2, you just have that little UDP layer, which if you're a networking guy, you know is small. And then you've got this massive Quick layer, and yes, Quick is a pretty big component. But, and then the HTTP2 API at the top is unchanged. So it's compatible with existing HTTP applications. Okay, this is where Quick starts to get really awesome. So with HTTP2 over TCP, you have stream multiplexing. You've got maybe a JavaScript file, an image, and some other resource for a page. And then HTTP2, formerly known as Speedy, puts it into a stream. Each packet is for a different resource, goes through the internet, and then it comes out on the other side in the same order, because that's all TCP knows how to do. And that's great until you lose that red packet. If that red packet gets dropped, then all the green and blue packets are blocked until TCP can retransmit successfully that red packet. And so your entire application stops loading. But TCP is just doing what it's supposed to do, and it's actually really good at it. We've been using it for 30 years. Amazing. Quick though Quick does what it wants. And if that red packet gets dropped, it only interferes with the red packet stream, and the green and blue packets continue without having to be stopped. So you do have head of line blocking, but only for that one stream.
So are these streams multiplexed over, like, what do the dotted lines represent? What letter are they?
That is a good question. I bet this source is going to. But, oh, hey, look, it's Google Slides. Anyway, you can,
I'll look it up.
yeah. Oh, man. Okay. Why fewer packets matters, I think we all get that. I'm still blown away that the quick handshake is 1 or 2 packets to establish the entire TLS handshake equivalent. Quick also has forward error correction. You can lose 1 in 10 packets without any packet loss. It can reconstruct those on the fly. Basically, he says it's like grade 5 on the network level, which is sweet. So you do have a 10% overhead, but you have a lot of optimization to make up for that. This is my favorite feature of Quick. You guys, I can't wait for this to become like the standard, because this is great. How many of you have been downloading something on your phone and then walked outside and then your download gets interrupted because you switched from Wi-Fi to cellular and you have to refresh? I hate that. Quick, you don't have to worry about that. Because with Quick, you can be downloading on Wi-Fi, switch to cellular, and then it just keeps working. Because of how UDP uses a connection UUID. It's like a 64-bit number. And if you've ever used the MOS shell to keep your SSH connections alive when you are traveling, it does the same thing. So those are the benefits of Quick. Same things here, same bullet points. Any questions about Quick? Yeah.
So how does it, so it's consuming the TLS layer, so is it TLS or is it just like totally different transport layer security?
It uses the same ideas as TLS. I think, because right now it uses TLS 1.2 more or less. And I know that there's some more research being done about the security implications of that, because it's not an exact de facto transfer over, I don't think. But I know that Quick is not going to be released before TLS 1.3, and I know that they're migrating the Quick, again, I don't know how they're doing it, but they're migrating Quick to TLS 1.3 already. So it's essentially TLS, but it's with UDP. So that's all the technology that I wanted to talk about. It's been 50 minutes. I'm probably just about done. So there's this wiki page. I just kind of wanted to show you really quick. I'll just spend a minute. Caddy is extensible with plugins. So if this is what your appetite for web technologies and you want to hook into this, you can use Caddy for your own needs by writing a plugin for it. Of course, these plugins are written in Go. They allow you to do a lot of things. The Caddy's HTTP capabilities, that's a plugin. So if you want to serve something other than HTTP with Caddy, like if you want to serve DNS or mail, go ahead, implement a mail server and go, and you can just plug it in. And the cool thing is that any other server type like mail or a GET server or an FTP server can all take advantage of Caddy's TLS features with just a couple lines of code. So a mail server that always uses start TLS, or an FTP server that's always secure, or a GET server that always uses HTTPS. You can customize how the Caddy file is loaded. You can add new directives for the Caddy file, like the GET plugin, for example. Very easy to write. It's just a package with an init function, and you just call caddy.register plugin. And then to plug it in, you just add an import statement. So it's all still statically compiled. And then these are the tutorials for how to write a Caddy plugin. Again, my time's up, so I won't be going into that. And then you can add them to the download page. So when you go to when you go to the download Caddy here, these features here, these are all plugins. We'll very soon be adding a DNS one here because a developer, his name's Meek, has been working on a DNS fork of Caddy, and then that's what kind of inspired us to make it a plugin. So you can now run Caddy very easily, something like that, and then you just give it the Caddy file, but a Caddy file that's written for the DNS server type. And you get all the same advantages of Caddy, but it's not even for HTTP. So this is like real, and it's awesome, and I hope that you'll take advantage of this in your own Go programs, because you can also embed Caddy in your own Go program very easily. Caddy's a package. You can just call load Caddy file, call start, and then you can just wait for it to unblock. Yeah.
Have you been approached by anybody else either wanting to sponsor you or to work with or pay for your to develop more?
Yes, I'm really glad you said that because I didn't mention that earlier. Oh my, they're gonna kill me. So, yes, Caddy is being sponsored right now, actually on the download page here, or on the home page, I should say, by Arroyo Networks and Minia, and I greatly appreciate their support because for the last year and a half, I have been doing my own consulting or contracting work, as well as working on Caddy between that. So that has actually helped to further its development. If you're interested in sponsorship opportunities, I don't normally forget to mention that at the beginning of my talks, and I would be happy to talk to you about it. So I think that's it. Thank you very much for listening. Are there any questions?
I have one. So I was a little bit distracted when you started talking about your plugins, but from what I gathered, you import Caddy, you have to have an init function, right? But then you just recompile Caddy with your plugin. Is that the way it works?
Yep.
Okay.
Yep. So completely static still.
Cool.
If recompiling is an issue, then you can use the download page because it does that for you.
So what about SSL offloading? How would that, like we're a big enterprise with thousands of web servers, they're all SSL offload with F5s. Would you still be expected to offload SSL, or does Caddy, was that not needed anymore if you're running thousands of Caddy servers?
Good question. So, some people use Caddy as their load balancer. The proxy directive allows you to specify in as many upstreams as you want, and it has load balancing policies you can pick, and health checks and things like that. We're working a lot on the proxy, a lot of contributions coming in even today on the proxy directive for those kinds of things. So if you want Caddy to manage your SSL for you, I say SSL, it's a bad habit, TLS. If you want it to manage your TLS for you, you can put it in Fred. If that's too scary, put it behind. But I wouldn't use Caddy as a TLS like certificate manager just for that. Use it as a web server. So if you have Caddy behind your load balancer, do you still need TLS? Is that what you're asking?
So I'm asking, so if you are doing a large scale, whether you're doing proxies or you're actually hosting a website with Caddy, would you want to do TLS, SSL, TLS offloading on an F5, or can Caddy handle that?
So the offloading would happen in front of Caddy?
Yeah, like on an F5 load balancer.
I mean, you can do that, I guess. But if I don't know, if you want Caddy to manage your TLS assets for you, then you can't do that.
I think what he's asking is traditionally using a secure protocol on something like Apache, that is actually a performance hit, or traditionally it's a performance hit. So a lot of people would offload SSL as something like an F5 load balancer.
Oh.
Yeah, I'm wondering about performance.
Well, you're asking for performance.
Mhm.
Okay. Well, so that's going to depend. I would just recommend try it in a test environment and see what it looks like for you. Because I know that, again, some busy websites have been able to use Caddy and Front okay. And others are too nervous to do that for whatever reason. Caddy's not 1.0 yet. But it seems to be running well in production. Again, its TLS performance is the same as Go's TLS performance. So if you're comfortable having a Go program in Front, getting a lot of requests, then you should be okay having Caddy in Front. You may not need the SSL termination. But again, that depends. If you're serving millions of requests per second, maybe you should go for something that's built for performance. Yeah.
So we talked a lot about how Caddy's all about security and it does all the TLS for you, and it's kind of the security is really easy to use. Can you talk a little bit about the security of the application itself, like vulnerabilities, like maybe within this fast CGI environment or this kind of thing?
Yeah. Okay. So that's a good question. So vulnerabilities other than just at the TLS area. So that's hard to answer because have I fixed vulnerabilities in Caddy that are not like related to TLS? Yes. The only one that was really a security vulnerability in that sense that I know of was a side channel attack way back in like a year ago in the basic auth middleware, just because I didn't use a constant time comparison for passwords. Duh. But are there security vulnerabilities perhaps in using fast CGI or proxying? Honestly, probably. And I would love for people to vet it and improve it and responsibly disclose it, and we'll fix it. If you're using fast CGI, I mean, here's the thing. Like, if you're using fast CGI, like if you have a PHP backend, most of the vulnerabilities I've seen are on the PHP side of things. That's really it. So recently there was this, what do they call it, HTTP oxy. There was like this vulnerability where the HTTP proxy environment variable was a security risk. It wasn't new, it's like 15 years old, but got a lot of hype a couple weeks ago. And Go was vulnerable to that. That's why they released Go 1.6.3, because it was because it would modify based on the value of that header. I guess it would conflate environment variables with headers and then use the value of that header to direct some proxy upstream. You could redirect it to your own thing instead of the right one. The web is complicated. Are there security vulnerabilities? Yeah, probably. I don't know of any outstanding ones right now. Any others?
Do you do this full time?
Right now it is. I start my master's program in 3 weeks, at which point I will not be doing this full time.
Where's your master's?
At BYU,
Studying.
computer science.
We're sorry.
Hey.
I know.
You came to the wrong meetup locations. Have that attitude.
Anything
So
else?
is there somebody else to take your place
I'm
while
not
you're
going to
studying?
disappear. I'm not going to disappear. There are other developers. Most of them are remote. One of them is here in Provo. And I mentioned that Mozilla funding. He's going to be helping me with the features that we need to implement for that.
While you're here, can you give us his phone number and address? Just in case we
I'll be around. But see, so here's the thing. We have a community forum. I'll show you. Forum.caddyserver.com. And I try to let other people tackle as many of the help questions as possible. I try and keep my time into issues and actually work on the development side of things. So, but again, over 90 contributors that have developed a code base, and at least 24 right now have push rights to the repository. And if you submit a pull request for something more than just like a one-line change, you attitude line change. If you submit like an actual bug fix or a new feature or something that checks out, we merge it in, we'll probably give you collaborator status because I can't do this all myself. So, we have a good community.
Do you see this as a good alternative for like NHA proxy? Is it?
Well, Caddy's first and foremost a web server.
Okay.
It does have reverse proxy capabilities, like I showed you or told you. Your user guide, and then down to proxy. This tells you all the stuff you can configure. Anyway, was it a good replacement for HA proxy and others? It could be.
HA proxy is different. You have to change the config file and restart it and everything. Okay, so you can make a cool program for Caddy that let you
Yeah,
change things on the fly.
So you're saying the HA proxy, you have to change your config file and reload it. Caddy lets you do that gracefully as well, but part of the features that we have slated for the next major milestone is an API, a REST API, so that you can use any client that you want to reconfigure Caddy dynamically, and also a web UI, so that you don't need to use the command line to run Caddy. Sweet, that's the hope. Well, thank you again.